write a contract specifying this. In my evaluation, days and years, the number, the maturity has computed according to this convention. Every debt contract, you don't notice because you probably have never read your deposit documentation, that small letter, specifies this. How days are computed according to which basis. Debt card, everything that has to do with fixed income specifies these conventions. So number of years will be 114, right, over 365. So we get maturity at 0.31, 23, 28, 7, 67 years. And now we need to go into this curve and look for that specific value. So this is the payoff of what we did. We don't have this maturity. We have maturities that have these specific values. So we need to figure out somehow, applying some interpolation method, whatever. That's exactly what we did this morning. And now that pays off. All right, I have the parameters, those are the solutions. Let's specify that. So in order to create my estimation, remember, we need to define the X1 value and the S2 related to this particular maturity. This is what we did here. X1 and X2 takes the values and that particular maturity. So I'm going to take the formula, Control C. I'm going to recycle this formula. I'm not going to type everything again when this was already done. I'm going to be more efficient. But copy-pasting in Excel, copy-pasting in programming is very, very dangerous. You're going to notice that when you learn mistake and Python. This, of course, is a shortcut. And I want to be efficient. And I have everything here. But this is a systematic source of errors if you are not careful. So I copy-paste the formula. I go to X1, Control V, and I paste the formula. The problem is that if I click on the formula, on the expression, what we have is that we are calling the right parameters, which of course are the driving parameters that we estimated this morning, lambda, that 0.50, 50, whatever, that's fine, but it's calling, in the formula, it's calling this value. This is what we need to be aware of to not to make the error, not to make the mistake, okay? So I'm gonna go to the S1 value that I have just copy-pasted. It's calling A2. Right now that's an error, that's a mistake. I need to replace that by this. And A2, I need to replace that by N23 in my case, okay? The worst class of errors are those that don't have an effect, an immediate effect, just like this one. I copy paste and I have a number. You do that in coding, you will not necessarily realize that you were making an error. There are errors that trigger the consequence immediately. You know, div, not a number, and you notice that something is wrong. This type of error will be very dangerous because I'm copy pasting a number in my workbook and I could make operations, but I'm not reading the right maturity, but the fair maturity that we have. Okay? So this is the right X1 factor, which means nothing to us. It's just an auxiliary step. And we are going to do the same thing with X2. I go to D, where we have the formula, and I underline the formula. I'm not just copy pasting, I'm taking the expression, Control C, okay? And then I go to the cell, I go Control V, and once again, I see a number. That's very dangerous.
But that's not correct.
But that's not correct because it's calling A2. Once again, it's calling C2 and A2. We need to fix both things. First of all, C2. C2 was the primitive X1 that we have in the table. I need to replace this C2 by this value that I have to the left. just as I had before. I need to replace for what is calling, right? This expression, x2, is calling what we have at x1, and then applying that correction, okay? So we have at n23, right here, and then we take the minus exponential of minus lambda, everything right here, but not a2. That was fine originally, but not in this part of the workbook. So we need to call the maturity in units. And now we are fine. This is the right value of x2 for this particular maturity. And we are almost done, guys. The final step. The final step is to compute the yield to maturity. And I'm going to, from next figure, right? That's my estimation. This is what everyone does, of course, fully automatized. They just, the guy in the bank presses a button, that information is automatically generated, but we are constructing that manually. So we need to apply the formula for the yield to maturity according to the model of Nelson Sevier. And that was, remember, this expression here. Beta 0 plus beta 1 times x1 plus beta 2 times x2. So we have this expression once again here. So I'm going to take advantage of the expression. I control C that. I go to the right place, and then we need to fix things. It's not calling x1 and x2. There is no problem with the parameters. The parameters were locked in. So I have beta 0, beta 1, beta 2 properly called. The problem is I'm taking K3 multiplying C2 and K4 multiplying D2. That C2 and D2 are the wrong references in this process. I need to replace C2, which is x1, by the position of x1 in this valuation. I need to replace D2, which is the value of x1, by the cell where x2 is in this valuation. And now I'm fine. It's okay, guys? You understand, right? It's a little bit, it depends on your positions, but I want you to get the idea. This is a mechanical thing. The problem, the very dangerous problem here, is that I get numbers. See, of course, it's a kind of number that makes sense, 4%. Not a weird number, because it's calling the other value. So the interest rate that we will apply to Natalia's operation will be 3.89%. This is risk-free. Now the question will be, is Natalia's risk-free? Probably not. Not. If you were risk-free, if we say Natalia's, our belief that Natalia will make this million in February is 100%. So we will be okay with this 3.9. But because we typically are not, we need to charge, and this is what the banks do, we charge a risk premium.
So what is the interpretation of 3.9?
3.9 is the position over here associated to this particular maturity. If you zoom here, you need to go to 0.3. Later we're going to change it, because now it's fully automatized. This was for Natalia. If you want else, we're going to put your birthday and see what happens. Because right now, the code is fully automatized. You change the dates and everything will be recomputed. And we will have to do nothing else.
So, we're going to do a function where we...
This is a function. This is the whole point. It's being automatized as the artistic part for what's estimating the model. Now that we have the parameters of the model, everything goes for free. You just change the value of the maturity, you change the date, and you will have automatically the fair value. Still under construction, still under way, closer and closer.
So that 3.9 is percentage, right?
3.89%. So we will have to remember that. And it's a percentage, and this is a very good observation, Alex, because the original data was in percentage. I work with those units, we get those units, but I cannot plug in those units right away in the formula. We will have to divide by 100. So that's a good observation, and this is something that we will have to do later. All right, so risk premium, 2% for Natalia, kind of friendly, or do you want to charge something bigger for her? Jose Maria, 2%? 2%, no more. 3%.
She's not giving me the video back.
Angel has from the real sector. Angel has experience. You know, they will say, okay, what if 2.5, right? She won't notice. She won't notice that.
She will notice. Let's put 2.5 on the side. We say it's 2 and it's not false in reality. It's 2 something.
We value that, and this is fair value. It's called fair value because let's say that auditor comes to our back office and say, why did you charge that? And we will explain our operation step by step. See, I did that thing. We look the real rate that was for a risk-free operation, and then we determine according to our risk control and risk department. I call Angel, the head of the department of the risk, and he told me 2.5. 2.5 is.
2.5. We don't believe fully in her.
Right? So this is the. That's what we are not charged because it's risky. So the full thing that we apply here in this operation is 6.39 year. Just 2.5 arbitrary. We decided that 2.5 would be okay. And probably she will have something to do. She will have something to say like, 2.5, but most often they don't realize. I don't know, I just went to the bank, and the bank told me this is the fair price, and there's a lot of information talking about weird operations that I had no idea. They just give me some cash. So we are kind of price takers when it comes to relationship with the people in finance. And they take advantage the hell of that. You don't know, you don't care, wait and see. All right, so this is the rate that we are applying. Now we need to determine the discounting factor.
How did you calculate the rate?
This plus this. 6.39, and you may say, why not just 6.3? Because people in the banking industry don't go like that. They will charge you every decimal possible. And if this 6.39.5, when applied over a million, makes a difference, which is my money. So I will take into account all those decimals. And every day, every little margin counts when you apply a lot of operations over a lot of volume. So they are well aware of that. They do operations with an interest rate which is called the overnight rate. You have heard of that. They borrow and lend overnight, and they charge something for the hours that been at night.
They also pay overnight.
Of course, borrow or lend, and it's agreed. Everyone understands in the industry that money has a price, time has a price, risk has a price. All right, so we know to determine the discounting factor. Discounting factor is this thing. This is the number that we will multiply the cash flow in order to show the present value corrected by time and corrected by risk. So this guy is going to be 1 plus the rate that we are charging. But like Alex pointed out before, this is in percentage. So we need to divide that guy by 100. 6%. Numerically, 0.006, right? Needs to go in. The discounting factor is dividing. So I'm going to use this notation. I can write something divided, right? I can say something like this or like this. I prefer to do that because it's kind of more compact, right? So I'm going to multiply everything, and we are going to rise to the power of the maturity, because we have perfect agreement in the operation. The rate in this operation, right? The rate that we are applying, that we are charging, is expressed in percentage, and it's expressed in years. This is the 6.3% annual, and I can compute here the number of years. So this is what I have here, 0.31 years. Everything is measured in years. We have agreement in the units. So that's the discounted factor. If we want to compute the present value of the million of the Natalia's million, we need to multiply, and that's the final part, the present value, right? The fair value. We need to multiply this thing, the million times the discounted factor. So C gets 980, which is not bad. Then maybe we need to talk about commissions and fees. That would be the present value, you know, updated before fees and commissions. But you need to give up 20,000 for time passing and for risk if you want your money right now. What about if she was risk-free? Then the risk premium that we charge is just 0, right? That would be the best scenario possible for her. Then we just take out 12,000. Time passing means 12,000 in these 100 days. Is that understood, guys?
And you can do a Monte Carlo with the risk premium to see what happens.
No, you don't need Monte Carlo because you have fitted everything. You may change, if you like, the amounts, right? Let me sort of put that million here. I'm gonna just take like this and move it. And in Excel, this is perfectly okay because all the formulas are automatically updated. I'm gonna put this and I'm gonna put here the date, okay? So it makes this much more nicer. And you see, everything is sort of recomputed because the references are automatically updated. So like I said, what if we want to change that now that we have this thing? So Ignacio, your birthday is
September 2.
September
2.
2. So maturity would be September in 2026, right?
Yes.
That I did something wrong here, let me see.
Yeah, because September.
Oh yeah. September 2. So it's 300 days. For him, the yield to maturity at this 0.84 is just 3.66. If we charge no extra premium, then the million becomes 969. That if we go to 26, but if we go to 28, then that means 1,040 days. So this is 2.84, 9 years, and you see right now everything is done. You change whatever you want, and Excel is doing its magic. It's like the interesting thing of working with a programming. Now as a function, and it's giving us the present value.
So what do you put up? You do like the zeros.
Okay, is understood?
So,
So
you go to the left. So it's 1,040. What do you?
I take the 2nd of September 2028, 2 years ahead, meaning I can move as far as I want, not just 1 year. You have all this curve, you will be moving along this curve. And once we have getting the parameters that control the curve, and we have estimated that this morning, then we can determine the present value of everything. September. It's understood, guys? Because right now the next exercise is in media, where you have a much more complex product, such as something like this. I give you 10 minutes, guys, to finish it. You have everything you need. And there is just one final consideration here, and this is that because you have a contract which is more complicated, it has those 4 levels, to value every payment at once. You determine the present value of all of any of those payments, and the sum of the 4 present values is the total present value. We are working with just one payment in the example, where if we have 4 payments. The idea is the same. You need to value, you count days for each of those different maturities, 25, 26, 27, 28, determine the proper discounted factor, multiplying for the payment to get the present value of any of those 4, and then get this total sum, and this is what this contract will be valued. That's the fair value. And that information will go to the accounting department, and that will say, they will register that in the books. We have this right, and this is the present value. I give you 6 minutes. This is very easy to take advantage of the Excel that we have created. And you guys just need to copy paste, because the formulas will be sort of, if you take the birthday Natalia's experiment and you copy that thing with 4 lines, you will get substituting the dates and the payments, and you will have everything. You guys may notice little differences though, because we have estimated the parameters. So if your Excel converge to a different, slightly different values that I did, and this is very likely because we have different versions of the program. Even we have different, Mac, disease, you may justify different values. We don't care. It's fair value. I've done it. The point for us is to be able to justify why you say that this thing is 900 euros worth. And the point is, I did this analysis with these values, replicate my analysis, you will reach the same value that I did. So unless you have exactly the same coefficients that I estimated this morning, and that may be the case or not, you will not necessarily get exactly the same fair valuation. No one will care. It's what you do. I will say, okay, my point is, it's not that you are sort of, making this up. You have a solid analysis behind. That's fair value. I can justify what you do. And why I apply an interest rate of 3.9%? Because the same operation in the market today is rewarded with a 3.9% at that particular maturity.
And you used operation data as today?
We did it, well, it wasn't today, right? It was 25, so it was probably yesterday's. Okay? So strictly speaking, that was 27, so that was yesterday's. So strictly speaking, in the operation date, we should write, not today, but 27th. The point is that we don't have the 28th curves yet. As soon as you have it, you will have that thing. We will repeat this evaluation, just valid only for this curve. And this curve is just valid from the 27th. Tomorrow we will repeat with the new information that we have. This is what banks do every day. Of course, you put the date, and that goes into the database, and the analysis is made with that specific data.
What is the operation date?
What is your?
What is the operation date of each?
Strictly speaking, if we want to put it, the operation date should be 27, because we were working with the, not today, so we want to be purist, this curve, so let me correct that. I'm going to take, that's a fair repeat. 27 of October 2025. That's fair. Now it's exact. An auditor can come here and say, but Antonio, we did this thing. Take a look. Someone from accounting will not understand not even a word, but will see, man, you are doing things, I understand, that this sounds sound to me. You may go into, a core and present evaluation, and everyone we are agree. In consultory, you could support the evaluation. Look, we should give her 900. If the bank gave her just 800, they sort of rip her off, right?
Gave me 1.46 million.
1.06
No, 1.46 million, the present value.
Can I have,
of everything.
can I have the, the document, the image of the, no, the cash flows,
The what?
los valores,
Y el de
Eso.
receiving is the same.
gracias.
Important thing.
Almost.
It's like a 1.3 million if we don't take into account the value. So it must be something between 1 million and around one, something greater than 1 million probably. You have to say, of course, it depends on the curve. And you see the shape of the curve determines everything. You may apply a shorter rate in a very short maturity, but then a longer rate, a longer maturity as well. Or not necessarily, just depending on the shape of the yield curve. ¿Cuánto? 1.47. Bueno, 1.047. O 1.4. No puede ser. No puede ser, Jesús, porque mira la suma aritmética. Tienes que paralizarlos, los tienes que descontar. No puedes sumar más que sin descontar. Y se estás aplicando descantifactos. ¿Eso bien? ¿Lo tienes cuánto?
1.39.
1.39. Eso suena bien. 1.39. 1.39.
117.
117. Let's solve the problem. Okay, so I'm going to recycle this structure. Operation day. I need 4 levels. So 27, 27, okay. Maturities, we have 24, 25, 14, del 6, del 26, 18, del 12,
Ah, no, que me equivoco, no, 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 no.
17, 25 de julio de 2021.
Vale, ahora sí, 138.
Tenemos 350.000 por aquí, 450 por here. I'm going to copy paste this format, right? 225 and 474. Now, number of days. We copy paste down, copy paste down, copy paste down. We have the yields. And see, 3.98, 3.74, 3.45. And it's changing depending on the horizon. Specifically, targeting the specific horizon we need. We are charged at 2%, 2.5, well, the exercise said 2%, right? Yeah, we charge 2%, so 2% is, this is the rate, that's the discounted factor, and that's the present value of the 4 gains. So the total thing is the sum, and we get something like a 1.39. Who said that finance is difficult? Who said that finance is not interesting? Huh? This is a real operation in markets, in operations. This is operations that consultants have to do. And they need to do like that. I'm not charging something because it's me who says, I'm going into the financial markets to look for comparable information. Why this 3.98? Because there is an operation, someone is trading in the financial markets in this particular day, no risk, charging this amount. And we are making this kind of arbitrage argument. If someone is doing that in the market, whatever is good for the market was good for Natalia, now it's good for this concept. I'm taking the reference, it's not me, it's an objective reference. And the only thing that we may criticize is why you charge 2%. That's what the bank charges to everyone in these circumstances. So that's the fair value. Okay? Now, the question would be, risk premium. We know what to do with risk-free rate right now. I need to go to the core, but 2% can be determined somehow, objectively, and the answer is yes, this is what we are going to do, exactly what we are going to do in chapter 2. We are going to review the models that sort of discuss the proper market-driven risk premium. Someone, just like someone is selling and buying bonds and that gives us a reference for the operation, someone is selling speculative assets, such as stocks and other things like that. Typically stocks, this is the speculative asset we are interested in. All right, we have models that tell us somehow how to measure the risk, how to figure out the amount of risk premium that is charged in the market. And this is the argument. If they do that in the market, maybe this operation is not part of the market. They're going to do the same thing. Okay, guys, 15 minutes break today, right now, and we do the transition for chapter 2. Questions?
Antonio, no, this is not a question.
This is
Everyone
not
will go to the break. I don't know if you have seen.
This is not a question. I already.
Confidence.
I'm scared. I want coffee. I'm not joking. I do want coffee, right?
We need to talk.
Yeah.
I don't know if you've seen Carmen.
No.
Said that
For the
que la sala de ordenadores no está de 11 a 11:30.
¿Y por la tarde?
Está de 2 a 2:30. O le puedo preguntar por la tarde.
podemos coger por la tarde, si os da igual. Es que me parece más seguro.